Okay, so today what we're going to do is build a weather app using weatherapi.com. It is free for some access, and then if you wanted more data, so further into the future, and things like tide data, then you need to pay for it. So you can see here we get 1 million calls a month for free, a real-time weather and 3-day forecast. Otherwise, you could even go to like $25 a month. We'll give you 5 million calls per month, a real-time weather, and 14 days forecast. When you pay, you start getting tide data, you start getting hourly weather data as well, and you get historical data for the last year, depending on your account. But you don't need to pay necessarily for just to build a weather app for daily data and for 1 day and last 7 days of history and 3 days of forecast. So that is plenty to build most weather apps to begin with anyway. Okay, so let's have a look at an example call. So when you sign up for Weather API, it will then allow you to access a key. After I've recorded this video, I will be resetting my key, of course. So this is private and secure. So the whole idea is that this key allows you access to the Weather API. And this is basically when you pay, the key becomes a pro key. And so I'm on the $25 plan at the moment. So what we're looking at is if you go back to the Weather API website and you go to docs, you can kind of see what the Weather API has to offer in terms of its structure. And you can see which ones kind of sit where. So you can see your request URL is api.weatherapi.com/version1. P1, and then you do a key as a parameter. So that means a question mark P. So how I would use this is I would use this URL, copy, paste it in here. I'll go question mark key equals, and I'll need my key that I had on the previous screen. And then you can go into current weather, forecast, history, marine, etc. And so you can kind of see as well, we also need a second parameter required. So you'd have to say key equals whatever it is, and then you'd say and Q equals, and then you can provide either a city name or a zip code or anything, one of these things. I actually prefer to use latitude and longitude because it's easiest for us to get. So you could put that latitude and longitude, in here as well, and that will give you the weather data using your key for that location coordinate. So that's kind of how we're going to use it. And then what we're going to do when we go into our weather data, we're actually going to have a look at the structure is all published here as well. It's in JSON format, JavaScript object notation, but you can change that too if you wanted to XML. And we see some error codes. It's the forecast. So for example, you've got forecast day, and then you've got things like in day is an element, and that has a max temp and all those kinds of things. So it's a bit kind of structured. It's not just flat. Okay, so I've created a sample API call using our key, our secret key, and the coordinates just for this classroom. It doesn't really matter where you are. So this is API data for my location. So I'm going to check pretty print so I can actually read it. So you can see location and has all these details. And then separately, we have a current. So it's at the same level as location. So in current is temp C, 15 degrees at the moment. So that's what I'm going to need. And also in forecast day, I've got forecast day, this is really important. This bracket here indicates an array, a list of forecast day. So you can see I've got an open bracket, a closed bracket, a comma, so then I'll have another forecast day down below. And so you can see temperature C is 13.64 forecast for tomorrow, and max temp is 23.9 for today because we're up in the first day, which is today. So each day that you iterate through will be the next day and the next day and the next day. You can see things like sunrise, sunset, moonrise, moonset, all these different variables. So I'd say as you're building your app, just start with a basic one with temperature and then come back to this API and then add the structure, things like wind kilometers per hour or humidity or wind chill, those kinds of things as you build them into your interface. So let's get started in Xcode then. So we're going to create a new project. Now, because this project is all online data, we don't need to store data anywhere. We're running an iOS app. Let's call this weather. Just weather, that'll be fine. We don't need a team. I've just got my initials and my organization identifier. I'm not storing data, as I said before. I'm just going to save this to my desktop for now. Okay, so we've basically got our basic app, which has just got our hello world, our globe, and our text hello world. So this is a view. So I'm going to create a new group from selection, create a views folder. I'm also going to create a new group from, just a new group, sorry, and this is going to be models. And we're going to start in our models and we're going to build some views. So let's create a new Swift file inside of our models. Let's call this weather. And inside here, we're going to have our class called weather. Now it's codable, which means that we can take our JSON data and we can put it back into our Swift class then. So that's really important. The other thing is it's observable object, which means as it changes, as it updates, so we might set a trigger eventually, or something like that that updates the data every hour or every few minutes or even every few seconds. And so every few seconds we need to update the interface. So this kind of works like a state variable does. Okay, so we've got current. So this is really important. So in our data structure, we have our current, and in there I'm looking for temp C. So within this is my weather. So I need to go weather.current.tempc in Swift. So we're kind of creating this current structure. Now I don't have a current weather, so I'm going to have to then create one. So let's go current weather, and this is our next class. And it's also codable, codable, and it's also observable because we don't just want to update the interface when our current or location or something like that updates. We want to update based on something inside of current. For example, temperature C, when temperature C changes, that we update our interface. Okay, so inside of our current weather, we've got our ID. I'm actually going to make it an integer, and I'm going to use the last updated. And it's just this number here. So that's an integer, so that's what I'm going to use, and that changes every time we update it. So let's return our last updated epoch. And so that's basically this here, but we don't know in Swift what that actually looks like yet. So our next step we're going to do is create a variable with that last updated epoch, and it's an integer as well. Then we're going to need our temp C as a double. And so that's basically it. Now we're getting weather.current.tempc. I've tried to, you can name these whatever you want, but then you need coding keys to match the data store. So I'm just going to leave these generic, and then we don't need coding keys. Okay, so that's basically our weather data done. So the next thing that we're going to do is we're going to connect to the weather store, to this API, and download the data into this class. So for that, I'm going to need a new Swift file. Let's call this one weather. Let's start with location first before we generate our API. We're going to need our coordinates, right? So let's create a location manager. Okay, so for this one, I'm going to import combine because I'm going to do things kind of at the same time to get our location, and I'm going to import core location so I can use coordinates. We're going to have a location view model. This is like kind of old school thought, and this kind of makes it a user latitude and longitude, and then we can update it. So we need published variables. So as the user moves, it updates. User latitude, and let's make it a double. And I'm just going to assign my latitude some generic, some default number. So that'll do, this one. And then published var user longitude as a double. Technically, you don't need to typecast because we're already sharing it as a double. And my longitude, my default longitude will be just this classroom. So again, you can actually put that to 0 and then say if it's 0, then, you know, just show like no location set. We're going to get our location manager. Seal location manager, initialize, override our initializer. Whoops, and we didn't need our latitude and longitude here because we're kind of initializing it with values already. So we're going to go super.init, so initialize it, and then self.location-manager delegate. We can make that ourselves, so we can kind of like circular. Self.location-manager.desired accuracy we can do, and then we can actually change, so core location accuracy best, and you can kind of see it comes up with a few reduced kilometer, 100 meters, etc. So we want the best accuracy that we can get. Again, that's just rule of thumb. We don't actually necessarily need really good accuracy for weather data. Self.location-manager.request when in use authorization. So that is really important. because without the authorization from the user, we can't then use the use the location data. The last thing is self.locationmanager.start updating location. That basically initializes our location manager and starts building it. Now, we can't create this delegate, so we're going to actually have to then kind of make an extension to this location view model. And then because it's saying like we don't have the core location manager delegate, we're going to then create one here. So that kind of fixes that problem. But for a delegate to work, we actually need to then kind of tell it what to do. So we're going to look inside of this delegate. We're kind of overriding a existing location manager. So what I'm looking for is the did update locations. So in this list, you can see did update locations. That's the one we need. So I'm going to hit return and it puts it in. So the core location manager did update locations and it gives you a list of locations as an array. So that's really important because we just want our last location. So let's try find our last location. Locations.last. Otherwise, we'll just return, which means we just don't do anything. We don't update our coordinates if we don't have a last used location. And so as the user moves around, the location updates and it continues to update our locations. Okay, so then we can set our user latitude based on our location coordinate dot latitude, and we can do the same again for our longitude. Location coordinate longitude. So then we basically update these published variables based on our user location. Before we move on, when we're requesting our when in use authorization, it's going to pop up on the iPhone. So at the moment, that's not going to happen until we go up to our weather and we go info, and we're going to have to add anywhere in here. You just use the plus button here. We're going to look for privacy, location, when in use. I like the always and when in use usage description because it kind of covers more cases. And we're going to put in whether app needs location. So this goes to the user for weather. App needs location for weather. Something like that. So you explain to your user, well, why should I confirm like that the weather app has access to my location? And so then you say, yep, it needs access. So that's kind of our location manager done. The next step is to basically create, similar to our location manager, our weather manager. So at the moment we have our weather, but we actually also need our weather manager. And the weather manager connects to the API online, does all that magic, and will make your app have real data. Okay, so I'm going to import SwiftUI, import online. Okay, so we're looking at a weather manager which connects to our online API data store. So we've imported SwiftUI and we've imported Combine. So our next step, we're also going to, well, actually, I'm going to use core location as well. Core location, just in case. So we have our weather manager, and it's going to be observable object, which means it updates. We've got our key. And that key comes from our weather API. So my key is this, and I'm going to change it as I after this video, so that if this goes into public hands, that not everyone can access it. So you're going to need your own key. Static let the base URL is going to be our API weather JSON. And we can even put the key in there like that. So I'm going to go HTTPS // well, actually it gives me that already, so that's great. APIweather.com. I'm going to use forecast. It's actually, in this case, forecast actually gives you current as well, so that's good, because if you just used current.json, it would just give you current and it wouldn't give you the forecast, which could be convenient for later iterations of this app. So our key, I'm then going to access the key, this key here. So that kind of means when you're coding your app, you can use the static base URL for weather API, and it makes it easier to copy and paste the key, easier to find the key later when it gets changed, because you might change it sporadically, or occasionally you might change it once a month or something like that. So it makes it easy to update this app. Okay, so that's basically our weather manager for now. So the next thing I'm going to do is create this network manager, and that's going to connect online. And this is an observable object as well, and it has a published var did change. And this one's going to be a pass-through subject, and we're going to look for the network manager, and never, and initialize. I'm just going to scroll back just in case you missed that. So we're creating this pass-through subject on the network manager. It's a did change variable, so we can now kind of push if we did change or not. And we're going to have a published variable var weather is going to be of type weather. Now this type weather we've actually already identified here. So weather.current.tempc, for example. So back in our weather manager. So we have this weather. Now, when we first start up the app, the weather doesn't exist, so it's optional. But when we did set it, when it does change, then we say, hey, we've got a did change, a network manager did change because now we have a weather object, and then update the interface. We've got a double var in here for some reason. So when we initialize, we're going to do something, right? So when we launch the app or the network manager, we're going to do something. So let's create a function. Let's make this a private function called getWeather. And so when we initialize, we want to get weather, kind of makes sense. We're also going to create a published variable called location view model, and that's going to be our location view model, and we're going to initialize. So that is linking to my location view model, my latitude and longitude, and then when we initialize, we basically request in use, start updating location. So in here, that's what happens in here. So we're kind of requesting our in use, updating location, that kind of thing. This is published, so we'll update as we go, and then we can basically get our weather using our location coordinates. So we're going to let URL be our URL string, and we're going to use the string for our URL is going to be the base URL. So this is weather manager, dot base URL. But then, so that's only the URL, right? So we've actually got to add our query in, remember? So that's the next part. So we've got our key, but we don't have the end q equals our coordinates. So that kind of goes in here, and q equals our coordinates. But we're not just going to use these default ones. We're going to use our location view model dot user latitude. Then I'm going to put a comma. There's no space between the coordinates. That's really important. So in here, there's no space between like the comma. So there's the comma, and so then we do location view model dot user longitude. So then we're passing our longitude and latitude along, and then it's expecting an else statement because we're using a guard. So then else, what are we going to do? We're going to return, which kind of just says like, just leave weather blank, or actually leave a URL blank. So that's our guard statement. So let's create then a URL session, shared data task with URL. So we're going to use this URL that we just created with our coordinates and everything like that. And within that, we're looking for our data, response, or an error in, and then I'm going to put that on the next line. So we've got an open bracket, which links to that closed bracket, and we've got data, response, error in here. Okay, so let's check for data first. So guard let data equals data. So check if there is data there or not. Otherwise, we're going to return. We're not going to do anything. That's the first thing. We're going to try a do try catch. So let's create a decoder. So Swift has a JSON decoder built in, which is so convenient. It means it already knows how to find and use JSON data, and we can then use that decoder to, in combination, with our codable objects or our codable subclasses to then pass values or doubles into tempc and then into this last updated and then into our ID as well. Okay, so we have our JSON decoder. So the next step is then very simply, we're going to, actually before we get started, our date is, there's a couple in string which we can play with, but this one here is probably going to be second since like 1970 in our date format. So let's create our date decoding strategy. Let's go second since 1970. The other option in here, yeah, and you can play around with these as well. You can defer to date, you can use ISO, milliseconds, or you can use a custom as well. So we're just going to use the default seconds because that's how most dates are saved. So let's let our weather object then. We're going to try the decoder dot decode. And it's looking for a type, right? So our type is going to be our weather. So that's what we're trying to look for. Dot self, that's our type, because weather itself is the class, but the type of weather from our data. And this is this data here, which we're going to return if we don't have any. Okay, so that's done. So our last step we're going to do is we're going to use the dispatch queue, dispatch queue, Q-U-E-U-E, main. And we're going to asynchronously async self.weather is going to equal our weather object. So then we're going to try decode it and then save it to our weather object. So that's our do, but we haven't actually got our catch. So if there is a problem, what's the catch kind of thing? We're going to print our error.localized description. You can even use that error.localized description and put that back to the user because the data task is actually got fairly well-written errors. The last thing we're doing, because we've got our dispatch queue and we're doing a data task, we actually got to tell it to resume because it will start paused. So I'm going to build that. Lovely, no errors. So that's basically our structure done. So then to see it in use, let's rerun our content view. I'm going to make this big. Now you can see hello world, nothing's happening yet. So to get it started, let's create our observed object as network manager. Network manager. And when we initialize it like that, when our view reloads now, it should hopefully come up with that prompt that asks for location because in our network manager, one of the things that we're doing is getting a location. It didn't. Interesting. Let's keep working. If it doesn't work, I'm expecting maybe it'll output an error or maybe it will ask once it uses the data within network manager. So if let our weather data be our network manager dot weather. So if there is weather data, because remember it's optional when the app first loads, there is no weather data. Then I'm going to do something. So let's say text weather data exists. Otherwise, I'm going to create some sort of text that says like loading or something like that. So you can see it says loading weather data, and then hopefully as the interface updates, as it connects to online data, it will then say weather data exists, and then we can actually use that weather data, something like temperature C. Let's run this on the simulator instead of on the preview. Maybe it just needs that location access prompt. So we seem to have a problem. It still says loading weather. App security has blocked clear text HTTP. So it looks like our URL has got a problem. We need to use HTTPS instead. So up here, I'm going to change this to an S and try running it again. Okay, so the only thing that we really changed is the HTTP is to HTTPS, so S for secure, so it's a little bit safer. So you can see then we've got our current temp C. So I might just add in here a specifier, and I'm going to go %.2f rounds to 2 decimal places. Yeah, I wasn't ready. So 2 decimal places, or you can change that to a 1, so it's 1 decimal place, or you can change it to a 0, so there's no decimal places. Before you try printing it and forming it up, what you generally would do is you would extract the subview for this one, so it's called extracted view. Rather than rename it there and there, you can do that, that's fine, but you can refactor, rename, and it renames this extracted view everywhere. So this is like weather view. So then you've got your weather data. So in your weather view, obviously to make this work, you need weather data. So I'm going to say let weather data be some type of weather. And in fact, we might even just make this weather. So then you don't even look in weather, you just look at weather current temp. See, that needs a weather in here. So our weather is going to be our weather data, like that. And then the interface looks the same, but this makes it so much easier as a coder then to update your body, because you can just update everything in here to update everything in here. You can do the same thing for this text, loading weather data, or you can just put that in a vertical stack and just do that in here. The loading screen, I don't foresee being too complicated. Okay, so that's this app basically done. The last thing I wanted to show you is how to add extra elements. So at the moment, we've only got the temperature, right? But if you go back, you can actually get, so just not only the temperature, let's have a look at the condition text. So fog, for example. So for me, I'm going to go back into my weather. I'm going to go current, temp, because I'm looking beside temp, we've got condition and then fog, right? So that's one more step in because we've got these squiggly brackets. So I'm actually going to need to create in our current a variable called condition, and it's going to be of type weather condition. And then I'm going to create a class weather condition, and its classes have capitals, codable and observable, just like the other one. And inside my weather condition, I'm looking for text, and you can look at icon and code too. So we've got our variable, called text, and it's a string, right? Because it's in quotation marks. So that's it, I'm done. So then back in my content view, because I've added that extra, I can then, inside of my view, I can create a vertical stack, and I can put my current temperature inside that, and I can put below it the text for the weather, current, and you can see condition text. So that's just what we put in there. And we should see 16 and fog. That's simple as. And you can see we're kind of going within condition. If you're looking for something else like humidity, because it's foggy, it's 100%. So humidity, again, you have to pay attention to where it is. It's inside of current, but it's outside of condition. So inside of current, so in my weather structure, I've got temperature C, condition, and then our humidity, right? Where was it? Humidity. And it's 100, but I expect, well, I don't know. I assume that it would be a decimal point number. So I'm going to make it a double just to be safe. That's it, done. So now JSON decoder will look for humidity and decode it. So the same thing again, I'm going to create some text below, but this time I'm actually going to put in humidity, and then I'm going to go to the weather dot current dot, and you can see it's their humidity, and you can see 100.000. So I'm going to use the specifier to round it to the same 0 decimals. So you can see 100, and humidity is a percentage. So I'm going to put the percent sign after. Simple. The same thing, so weather.current.condition, so just how we did in Weather Manager, in weather, we did our condition with our weather condition. We do exactly the same if you want forecast. So you're going to create a variable called forecast weather, and then have a look and basically follow your source data structure from the data provider, in our case, Weather API. I hope that was useful. Good luck on your weather app.